Hello and welcome to day 5 of distance learning for Algebra 1. So we have in fact made it to April break. So it's the last video you'll be watching before you have a week off. You can use that time to get caught up on any quizzes that you have not yet completed. You can relax, read a book, get outside, hopefully it's some nice weather, but stay safe during that time. So again, this video is going to be posted on Thursday, April 9th for my A-Day students, and even though it's technically an A day on April 9th, I'm going to be posting the link to it for my B Day students on April 9th as well. And that is because Friday is Good Friday and we would have had no school, so I want to give you access to this video before you actually go on April break. So one thing I want to note, the first 3 videos I made were all units that we went over in class. So it was very much review. You could have gotten away with not watching my instructional video and then trying out the quizzes. But as of last class, that last video when we started slope, this is all new stuff. So these videos are going to be super important. Just like we did notes in class and we did some examples together, this is that lesson part. So the instruction's happening now and then the quizzes will be your practice. So just like I did in the last Google Classroom, the last day I posted, I'm going to post a link to the notes that you should print out if you have access to a printer, or at least handwrite on a separate sheet of paper. That way you have the examples that I'm about to go over on our whiteboard in front of you when you do your quizzes. Just a hint for your quizzes, these 2 examples are going to be questions on your quizzes. So if you are looking to get those right, I would strongly encourage you to write down those 2 examples so that 1, you have examples to use, and 2, you have the answers to 2 of the questions on the quiz. So if you have not yet done so, hit pause on this video, go back to Google Classroom, open up this link to Google Doc. You can either print it out if you have access to a printer, or at least copy down the template. So copy down the words up here, including your slope formula, which we'll talk about in a second. And then we're going to go through 3 examples like we would in the classroom. So take a second to copy that down. I do want to do a very quick review. So the last unit that we went over, or the last skill, that we went over was finding the slope from a graph. And we talked a lot about it being the rise over the run. So slope is the rise over the run. So it's comparing those 2 changes. And that includes the change in y, so delta y, the change in, so the difference between your 2 y values over the change in x, your 2 x values, so how it's moving horizontally. So in order to do that, I can count using 2 good points. And we're going to talk about what good points are today in our examples. So when I'm talking about slope, I can actually use m. M is the variable that we use to represent slope. And for our case, we're going to think of it how the line is moving. So the slope represents how the line's moving, the steepness of it, just like we talked about in the last video. So when I say 2 good points, you should be able to tell me the coordinates of that point. Otherwise, it's not a good point. So if I take a look at this point right here, I didn't move right or left, so my x value is 0, and my y value is down at -2. That's how I know that's a good point. I'm able to tell you the coordinate of that point. Same thing with this point. I can tell that I went over to the right 2, so my x value is 2, and then my rise or my y value was 1. So because I can tell you the exact coordinates of those points, those are considered 2 good points. So now I can count my rise and compare it to my run. So my rise is going to be how many units, how many blocks it takes me to get from this level up to this point. And I can't go diagonally. I have to go straight up or down. In this case, I'm going up, and I notice this slope is heading up in the direction from left to right, which means it is in fact a positive slope. So if I count my rise, 2, 3, I notice my rise is up 3 units. And that is because it takes 3 units to get in line with my new point. My run is how many blocks it takes to get over either left or right. In this case, it's 2. So the slope of this line, the graph that we have there, is a positive 3/2. And to confirm that, my slope is heading in a positive direction. So very quick note, we talked about this last video. There are 4 different types of slope. A line heading in the positive direction, the negative direction, which would be heading down in order from left to right. When we have the zero slope, when the distance isn't changing at all, you're staying exactly the same. Or when your slope is undefined. Remember, this isn't even a function. It is the vertical line test. It fails it, right? So we're going to take a look at doing one more example by a graph and then using that graph to show what the slope formula is. So I'm going to get rid of this. I'm going to put up a new graph. All right, so again, we have our x-axis and our y-axis. And again, I could see two good points. And those good points I'm talking about is when I can tell the exact coordinate of that point. So if I'm looking at this point, if this is 0, 0, my x-coordinate is -2, my y-coordinate is 1. So I went left 2 and up 1. We're going to use this further point over here. This is at 0. I didn't go left or right, but I went down 1, 2, 3. So this point is at 0, 3. Sorry, -3. We went down 3. So our two coordinates are at -2, 1 and 0, -3. And so all I've done so far is picked out two good points. And when I say good points, I was able to tell you exactly the coordinates of those points. Before I do anything else, I have to decide what type of slope. Is it positive, negative, undefined, or 0? And in this case, if I'm reading my graph like I would read a book, it is heading down in order from left to right. So it is in fact a negative slope. So when I go to count my rise and my run, I always start at the point on the left. So I'm going to start way over here. And in this case, to get from this point to this point, I'm going down. So I'm going down 1, 2, 3, 4 units. And to represent going down, it would be a -4. So I have -4 there. And my run would be over here, 1, 2 units. But again, because you're a mathematician, we know that we can't leave our fractions like that. We must simplify them. And a common factor between -4 and 2 would be 2. So I could divide both the top and bottom of my fraction by 2. And the slope of that line would be -2 over 1. You could simplify that and write it as a whole number of -2. But for us, leaving it as a ratio of -2 over 1 is totally fine. So that is our quick refresher of looking at finding the slope from a graph. But now, what if we don't have a graph? What if I was only given 2 points to find the graph? Now we know what this graph looked like. Sorry, got cut off, but we know what this graph looked like, and we know the 2 points that we were talking about were -2, 1, and then 0, -3. And we know that that gave us a slope of -2 over 1. So what I've done so far is just write our 2 points up here, -2, 1, and 0, -3. And we have a formula which we can use where we can actually count the change in y, or the rise, and the run, the change in x. So we can use this formula right here. So again, if you need to hit pause, this is a good time to stop the video and write down this formula. So m is going to be equal to the difference, or the change in y, so your second y value minus your first y value, over the change in x, which is your second x value minus your first x value. And so what you need is 2 points and to be able to use this formula. And so the first point, right, the ones, is made up of, and every point has an x and a y value. The first number you see is the x1 value. The second number you see is the y1. So that's all part of point number 1. The second point is made up of a new x value, x2, and a new y value of y2. So we have 2 different points that we can input into our slope formula. So I'm going to find the slope of this line using the slope formula and not just count the rise and the run. So we have our 2 points. The first thing you have to do is actually identify which value is what. So in my first point, I have a first number is the x, the second number is the y. So in this case, -2 is going to be my x1 value because it's in the first x position. My 1 is going to be my first y value. So again, every point has an x and a y. The second point is made up of my new x and my new y. So 0 is going to be my x2 value. -3 will be my y2 value. So I've marked out which number represents what point or which coordinate here. So I can use my slope formula, which would be equal to m is equal to y2 minus y1 over x2 minus x1. And I'm just going to plug in each of these values in for my function. So my y2 gets replaced by whatever number is being represented by my y2 value. In this case, that number is -3. So y2 is actually going to be -3 minus my y1 value, which is 1. So I am plugging in those numbers for their correct position. My x2 value is 0. My x1 value is -2. And here's where you have to be very careful. It's 0 minus -2. So I have to keep that -2 separate from that subtraction sign. So once I substitute my numbers into the correct position, it's just a matter of simplifying. So I need to use subtraction. If you need to use a calculator for this, you absolutely can. Just be very careful the way you're plugging it in. So m is equal to -3 minus 1. So m would be equal to -3 minus 1 is actually going to be -4. And 0 minus -2 is actually 2. Remember, some of you think about keep, change, but in this case, subtraction of a negative is really like adding a positive. So 0 plus 2 would be equal to 2. And as we know, when I simplify this fraction, my slope is equal to -2 over 1, which is exactly the answer we got when we counted our rise over run, -2 over 1. We're going to look at one more example. So in this case, it's going to be example number 2. So if you have this sheet printed out, this is where your example is going to go. Erase this. We are going to change our 2 points right here. And so the first point is going to be at the coordinate 2, 1. And my second point is going to be at the coordinate 8, 9. So before I do anything, I should mark out which number is representing my x1 value, my y1 value, my x2 value, my y2 value. So in this case, 2 is my x1, 1 is my y1, 8 is my x2, 9 is my y2. So I've just identified which number is representing which variable in this case, or not variable, which term in this case. So now I'm going to take that same formula and substitute in for my correct numbers. And remember, we are using subtraction, so I'm going to add in my subtraction signs right now. So my y2 value gets replaced by 9, and my y1 value gets replaced by 1. So the top of my fraction, my rise, is 9 minus 1. When I look at x2, that gets replaced by 8, and x1 gets replaced by 2. So now that I've set up my formula, I'm able to do the math, do the subtraction. 9 minus 1 is equal to, got excited, 9 minus 1 is equal to 8, and 8 minus 2 is equal to 6. But don't forget, just like the one on your quizzes, you have to simplify your slope always. So 8 over 6 can be simplified by a term of 2, because that's a common factor. So when I divide my numerator by 2 and my denominator by 2, I'm keeping that fraction equivalent, but my new number would be 4 over 3. So the slope of the line passing through these 2 points has a slope of 4 over 3, which means I can tell that that is a positive slope because of the answer I got. So today's video was a little bit longer, but it's the last one that you're watching before break. I hope you had a second to write down your examples. I'm going to post, just like I did last time, some extra videos in case you need to look at a few more examples before you try your quizzes. But enjoy your week off, guys. I really do miss you, and I wish you were back in the classroom. Stay well.